My name is Mukesh Kumar. I am part of Azure Database Platform in Azure Product Group. And with me, I have Narendra Angane and Kapil Samant. We are one of the Oracle and SQL and PostgreSQL experts within Product Group. Our responsibilities are to uh, codify and really simplify these migrations, which are happening from SQL, Oracle, mainframe, Sybase type of complex work platforms. In this session, our focus is going to be on explaining and telling you why Azure Database Platform is one of the best platforms for Oracle workloads. This is focused on Oracle Modernization, so we'll just be talking um, um, uh, multiple permutation combinations of customer asks, whether it's the technical aspects or functional aspects, right? And then what the complexities lie behind those asks, and what different paths of Oracle workloads you have and our customers have on Azure, right? What first party and third party toolings we have. Then Naren and Kapil will spend quality time on talking about different toolings details, first party as well as third party, and then we'll talk about a public case study, and then a very common but very complex use case of Oracle migration and how we are solving that for multiple enterprises, right? You building custom IPs on top of the first party toolings and product capabilities we have. Uh, and then we'll share the key takeaways and resources. And towards the end, we are available for almost 15 minutes for Q&A. With that, um, I would like to start by sharing some of the investments that Microsoft is doing, right, to really help you and our customers in this complex Oracle modernization. As you know, Oracle modernizations have different triggers, right? Like some companies are modernizing to really come out of Oracle costing model, licensing model. There are a few companies who are definitely looking at cost, but also trying to, realize new business functionalities, right? They want to reach to new market expansion, and the current OpEx budget that they have, they can't go with Oracle, and hence they are looking for, cost efficient yet highly scalable and robust database engines, and they're coming to Microsoft platform, right? But doing this, right, we do realize that giving customers just a product, right, or a tool is not enough, right? So Microsoft's investment, as you can see on this slide, is multi-tiered. We are investing in product services and migration tools like, as you know, industry-leading SQL product, PostgreSQL, Cosmos DB, Synapse, right, for analytics workloads. And then bunch of tools like SSMA, SQL Server Migration Assistant, ADF Azure Data Factory. Many of you might be knowing about all these tools. DAMT, which goes and does the code scanning inside application block. And then ADS, which is a new feature that we have released that gives you a single pane of glass for discovery, inventory, and assessment, right, and migration from Oracle to SQL DB and soon on PostgreSQL. On the similar line, direct product group engineering white glove is very critical because we do realize customers, while they might have Oracle or SQL or PostgreSQL expertise, that's not enough, right? There are so many moving pieces where a direct product engineering help is needed to aid what customers are doing, also to aid what customers contracted global system integrators or system integrators are doing, right? And that's another level of investment and incubation and innovation we are doing jointly together with customer. And good thing is with this, we are not just unblocking customers, but we are bringing a bunch of learnings back for our products and tools that we are again codifying and giving it back to community in terms of either product or services or custom IPs, right? And that's the third pillar where we are posting reusable IPs and custom solutions that are not yet codified in first party or third party product experience. And that is available on datamigration.microsoft.com. And there are other ways, like if you go to docs on a specific product docs site, you will find a bunch of these assets scenario based available for your consumption. Okay. Now, as I said, Microsoft is one of the best platform that gives you multiple choices when you are looking at complex Oracle workloads. Um, this slide actually gives you a little more depth, right, behind that statement. And please understand, this is not a sell slide. We are all engineers, and this illustration, right, like different Oracle workloads, app type, which are good fit and which would be easy target for all of us to go and modernize. What different database platform options are available, and how do you see them in very initial conversation with your customer, right? And before I go deep into this, I want to make sure that we are on the same page. Um, the the Oracle workloads, right, are very robust. Oracle as a platform is very robust, right? They do have a lot of salient features that are not yet available out of box, or the way Oracle apps expect database to behave. Those are not out of box available. There are refactoring needed, right? So not every app is a good fit for us to go attempt and claim that, hey, we can refactor or rehost, right? Or migrate. And that is where some of this due diligence we have brought, and we are proudly sharing with you that if an Oracle workload type, OLTP or ODS, right, and the application category is either ISV, custom apps, or Oracle apps, uh, how that metrics looks like on individual database engine, right? And then we have explained what RA means, right? So, for example, if there's an OLTP ISV apps, PostgreSQL is like, and hyperscale Citus is like home run for you, right? You just have to revise, and you can get the schema transferred into the table objects, right? And there are chances that data type built-in functions and majority of the inline queries will work out of box, right? Then on the similar line, you do have SQL Server, Azure SQL DB, and MI in the same category, right? And the reason it's still green is because while it has less language parity, it has more tooling capability and automation capability, right? For example, SSMA, the way ADF hooks up to this, right? Uh, and the way we have increased our conversion surface area, right, for data type and functions. SQL, all SQL targets are in the same revise or re-architect bucket, right? And so on, right? Similarly for Exadata, same metrics. We are very carefully recommending which platform and what mode you should be landing on. Okay. Again, I'm not going to get into each one of these, but this would give you a clue that how engineering is envisioning for each and every database engines for different type of Oracle workloads and app type, right? And how are we prescribing and suggesting GSIs and customers to look at each of the target in a proper context. Again, this is very initial thought process and recommendation. Things change because if a customer, let's say, super motivated to completely rewrite from Oracle to Cosmos DB, well, that's always a possibility, right? Or come to Synapse, that's always a possibility, right? So, but in most of the times, you and many of you and us, when we get engaged, right, customers don't know, right? Customers are looking at us to tell them where they can go, why they should go there, right? What does it mean for them to go there? And this slide really captures and explains them, right, neatly. On next slide, like I talked about, Oracle being a very robust platform, and some of the salient features that Oracle has, it's top notch in the industry, right? And as Microsoft, we are committed to make sure that customers, when they are migrating from Oracle workloads to SQL or PostgreSQL or Cosmos DB, right, they are getting that parity, right? And as I said earlier, there are different ways to achieve those parities. There are places where refactoring will be needed. There are places where we have built-in features, and we are striving and we are committed for the industry to go and make that built-in parity, right? In comparison to Oracle DB capabilities on our SQL or PostgreSQL and Cosmos DB. For example, Oracle Golden Gate, one of the niche feature is multi-region write, right? Well, you can, as you know, Cosmos DB can do that today, right? But if you have to do that on SQL DB or PostgreSQL, uh, there is a bit of refactoring needed, but it is possible, right? Similarly, for scale out, read replicas, right? Using RAC, the way Oracle achieves, we are attempting to go do that, right? Like through Cosmos DB, this is built in now. So, and then for in PostgreSQL, come use read replicas, right? And achieve the same functionalities, right? Um, and so on, right? Like this is a view to tell you that how seriously we are acknowledging some of the saliency Oracle has and how honestly we are working, right? To either have a built-in capability to a built-in parity to bring your workloads or workarounds that we can work together to implement. And end of the day, right? It always becomes that dollar versus some SLA sacrifice, right? Or some other non-functional SLA decrease. And that's a business decision. And most of the times we have seen serious customers are very uniquely and very I would say creatively, right? Uh, uh, Getting out of Oracle, right? Knowing all these salient parity gaps and refactoring aspects. Again, some of these are very frequent customer asks. Well, like, hey, how do we discover and assess Oracle data tiers? What are the target databases selected on Azure platform? Now, Naren, in next couple of slides, he's gonna precisely talk about these two aspects. Okay. And then Kapil will talk about and will do a demo around Oracle schema and object conversion, data replication and sync, right? And how do we achieve online migration for 24/7 workloads and bidirectional requirement for coexistence. Again, these are some of the top frequent customers asks, and you and I both know we have many more permutation combinations of asks that come, but our intent here was to bring something which we are seeing as frequently asked. And with this, let me hand it over to Naren to talk about those two aspects that I just explained. Naren, over to you.
Yeah. Thanks, Mukesh, for covering Oracle migration decision metrics and how to achieve Oracle salient capabilities in Azure data. So in this slide, you will see I'm showcasing you the three path offering which we can use a target for Oracle workload migration. And these three are a popular one which we can use to easily migrate your Oracle workload on the Azure. So first, we'll see the Azure database for PostgreSQL. This is a more popular when you want to migrate a Oracle workload on the Postgre. Why we are saying you actually prefer this Postgre as a choice, because Postgre is having a more compatible feature with the Oracle. Then it also support a large database like Oracle is supporting. Again, it also provide you the PL SQL compatibility with the Oracle, so that it will help us to run the application without putting much effort. Uh, this Azure database for
Naren,
PostgreSQL, yep.
sorry to interrupt. We can't see your screen, so if you don't mind sharing, please.
Oh, sorry. Share my screen. 1 minute. Are you able to see my screen now?
Yeah, thank you.
Okay, so I'm talking about the Azure database for PostgreSQL as a popular option to run the Oracle workload on that. It provides you the capabilities where it supports a large database which you are running on the Oracle system. You can run those on PostgreSQL. It also having a better compatibility with the PL SQL. So if you have a huge code which is written in Oracle, and some customers wants to migrate those database on a Postgre environment, in that case they are actually worried how we can actually migrate the database with the huge PL SQL code. But here the Azure database for PostgreSQL come to save your life, because what it will do, it is actually having a parity with the PL SQL so that when you migrate the Oracle databases, it automatically convert lot of code. Only few places you need to do a manual intervention, but it will allow you to migrate the PL SQL very easily as compared to the other targets we have. Uh, Azure Database PostgreSQL is also available in various flavor in Azure platform, like single server, flexible server, and the Citus server. So based on the business requirement and based on the technical capabilities, customer will decide which SKU they can use for the Oracle workload. Now we'll talk about the Azure SQL. Azure SQL is another option customer can use, which also provide you a lot of benefits when you move the Oracle database to the Azure SQL. It also coming with the various flavor, like it come with the Azure SQL DB, Azure SQL MI, and it's also provide you the Azure SQL hyperscale. So based on the business needs or based on the technical feasibilities, customer can decide which option is better for them. It's also provide a rich capabilities in terms of performance, storage, compute, availability, and the security. Uh, then another aspect, actually, Mukesh already touched that lot of first-party tool and third-party tools available for Azure SQL, which help to migrate your Oracle database very easily on the Azure SQL platform. So these tools, actually, I will showcase you how you can use it in my next slide. Let's talk about the third option, which is Azure Cosmos DB. Azure Cosmos DB is actually coming to the picture with Oracle. Oracle actually having a feature like a multi-region write. And if you want that same capability, but customer is ready to move from the relational sources to the non-relational sources because of the business decision, in that case, Azure Cosmos DB is a perfectly fit for this option. And Azure SQL also give a guaranteed SLA for availability, consistency, throughput, and latency. So customer can use the Azure Cosmos DB if they have a requirement where multi-write region capability is required, and they are ready to move from relational to non-relational. These three services, which are showcased here, is also provide you a lot of feature. Like these are highly scalable. Highly scalable means they can scale up, scale down on demand. So there is no need to actually provide provision CPUs and provision memories. You can actually reduce or you can increase based on your requirement. It's also provide high availability. This is because of the architecture and the infrastructure under the Azure platform. This also provided the intelligent performance. Here we actually added a various features in these services. These features are help customer to capture the performance gain, how they can gain the performance, and what it will do. It will try to implement those guidelines on this workload, and this is how you can get the better performance. It also helps you to maximize the control and fully manage. So in this case, you don't need to worry about the backup restore. You don't need to worry about the patches, and you don't need to worry about the infrastructure changes. Azure also provide you the proven resiliency and scalability. It also help you to provide the enterprise ready services. It help you to lower your TCO, and it also provide you the built-in security, which help you uh, to secure your data. Again, there are other services which you can use without moving the data from these services. Here, the Power BI you can use for the interactive reporting and for dashboarding. If you have any machine learning requirement, in that case, you can use the ML Studio, which is available in the Azure platform. And if you have any artificial analytics requirement, then you can use the AI services, which is available in the Azure platform. Now I'm moving to the next slide, which talk about the tool set for the Oracle modernization. And I love this slide because in this slide, I am explaining the migration phases, and for each migration phase, which tool actually we can use. So let's see first go with the discovery and assessment. In the discovery and assessment, we can discover the database, Plus we access the database and we'll see that whether that database is good to go on a target or not. Okay. Then in the object and schema migration phase, we'll check the we'll convert the schema from source to the target. Then in the third step, data migration and ingestion phase, where we decide how we want to move the data from the source to the target, where we can use the initial load or we can use the incremental load, whether we can do that offline or online, whether we need a cutover and how we'll do that cutover. All decisions are actually taken care in this phase. And the last phase is the data validation, which comes after the data moved to the target. We want to make sure that the whatever data is available on the source is now available on the target. Okay, so these four stages are available. And for these four stages, let's see now which tools we can use. So first, DB migration assistance for Oracle DMAO. This tool is we can use for the discovery and assessment. Then the database schema conversion tools, that is called DSCP, which we can use for the object and schema migration. These two tools are available as an extension in Azure Data Studio. And Azure Data Studio is a tool which you can install on Windows, Linux, and Mac OS also. So by using a cross-platform tool, you can also perform the discovery, assessment, and object schema migration. Then there are other tools like SSMA and Ora2PG. So SSMA and Ora2PG also perform the discovery and assessment, object schema migration, and the data loading. SSMA we can use for SQL as a target, and Ora2PG we can use for a Postgre. We actually recommend, if the database is small, we recommend to copy that data from source to target by using the SSMA or Ora2PG. But if your database is very large, right, in that case, we suggest to use ADF, SSIS, and MS Spark IP, which is our own internal IP, which is very fast in the as compared to the other in the list. We already tested this Spark tool with various customers, and we got the good feedback about this tool. My friend Kapil will showcase you a demo after a few slides. Then there is a data comparison tool. Again, this is our internal IP, which we can use for the data validation, and we'll make sure that our data from the source and target is same, and we are ready to use our target environment for the production. Now let's move to the next slide, where I am talking about the Oracle customer case study. And this case study is already available on internet, and I have also included the list in the resource section. You can click and you can get more detail. But let me give you the small introduction about this case study. So OBB is the largest mobility service provider in Austria. They did this migration for their ticket shop platform. Ticket shop platform is a multi-tenant one-shop stop for passengers buying railway tickets and using other services from OBB. Ticket shops serve multiple sales channels, including mobile apps, ticket vending machines, point of sale counters, and web services for its partners. They wanted to move from Oracle to Azure platform to save Oracle license costs and minimize the operational costs. And they reach out to us and they ask our help to decide the target platform. And we got engaged, and then we helped them to decide the target platform. And in their case, we use a PostgreSQL Flex server as a target because it's the ability to store large objects. The PL SQL is very much compatible with the Oracle PL SQL, which makes it easier for developers to code their application. It runs fully compatible open source Postgre. It supports the latest version of Postgre. It has a popular PostgreSQL extension. It also provides a customization for SQL configuration, and it delivers high availability configuration with the automatic failover capability using zone redundant server deployment. To migrate their 11 terabyte data, they use a stagger approach and move the data phases wise. For this, they use a stream and did the live migration to move the data from Oracle to Azure database for PostgreSQL. They also use the stream for streaming the data changes from source to target database in the real time. We help them to migrate the data and decide the target here. Now let's move to the next slide. Here I'm discussing the common advanced scenario for the Oracle very large databases. This is a common scenario when we wanted to migrate the Oracle database, large databases to the other targets. And we also did a various engagement where we help the customer to move very large databases. So I'm not included the name of the customer over here, but let me provide you the story how we have migrated the large database for one of the customers. So their concern is a licensing cost, huge Oracle licensing cost, and they also wanted to reduce their operational overhead. Uh, Apart from that, they also wanted to migrate their database within a 7-hour window. And within that 7 hour, they also wanted to migrate application migration and the housekeeping. Along with that, they also have one requirement where they wanted to move the EST time zone to the UTC time zone, okay, for their application globalization process. Uh, for that, they first decided to use the Golden Gate as a tool to migrate the data, but unfortunately, Golden Gate is actually unable to provide the performance what they are expected. That is not able to finish that task within 7 hours. So they reach out to us and they ask to help them. In that scenario, we ask them to use uh, our Spark-based IP, and they started using it, and we found that we are able to finish the uh, Oracle data migration within the 7 hours. And also we have migrated we also actually finished the EST time zone conversion to the UTC time zone conversion within that same window. Okay. When we migrated, we found that we got around the 350 GB per hour throughput. And they are successfully migrated the Oracle database to the SQL DB platform in that 7 hours window. Uh, I'll go to the next slide, and here I'm actually hand over to the Kapil, who will actually showcase you the demo how we can use the Spark-based IP to do the migration from Oracle to Azure SQL or PostgreSQL. Over to you, Kapil.
Okay, thank you, Narendra. So Narendra just talked about our internal IP that we use for one of our customers to get 350 GB per hour speed for data migration. We're going to look at the working demo of that IP. Before we go to the IP, actual working, I'll just talk about how it works and what is needed to run this IP. So it uses Spark as the data migration tool. And the reason why we're getting the kind of speed that we're getting is because we are doing it in parallel. So the processing that happens in parallel within the Spark cluster is what gets us the speed. So what we're doing here is basically, to put it very simply, we read the data from the database, we create a data frame, and then we push the data into target. But then the devil is always in the details. We do a lot of optimization, which gets us that speed. That's for the initial load. If you have an Oracle database where you're running a secondary database with an active data guard, which is a read-only copy, you can practically migrate your initial data without having any downtime, okay, or any impact to your production database. With that initial load, we also do CDC, but then CDC, getting the CDC is slightly different. We use something called as a Oracle's materialized view, materialized view log to capture the changes. There are various other ways of getting that changes. You could use log miner, you could use Golden Gate, you could use any third-party tool. But we went ahead with MView log mainly because we are looking at a certain use case where you want to enable CDC only on a subset of the table and not on the whole database. So what log miner does is it basically enables it on whole of the database and it hogs the CPU, right? So if you have a use case where you are running only for a subset of your transactional table, which is generally the case, okay, most of the tables that you have in your database probably would be static. So we then use MView logs on those tables to capture the changes and transport to the target database. We expect the schema to be ready on the target side. So your schema has to be migrated by using either SSMA or Ora2PG, which Narendra talked about in his previous slide. Even if you do not do it, the IP would take care and create the table, but you will not have any control on the data type that is being created. Because Spark will internally determine what the data type should be. So that's the working. And what's needed to run this is you'll need a few. So either you'll need a Synapse or an Azure Databricks as a Spark runtime. It has to run Scala 2.12 or later, mainly because we're using certain code that's dependent on this version. And we prefer an auto-scalable cluster with at least 2 nodes and up to 8 nodes. Okay, but then the number would depend upon the size of your data, your source database, your target database, because parallelism is amongst all three. Target and source and the Spark cluster that we're going to use. You'll need an Oracle driver to connect to the Oracle database. The version of the driver would depend upon the version of the database that you're running. In this demo, I'll be using Oracle 18c and OJDBC 8 as my driver. It has to have a network line of sight. The source and target should be able to see each other. If you're running it on-prem, you need point-to-site or site-to-site connectivity, and preferably an express route with a good speed to get the kind of speed that we just talked about. And you'll need an Azure key vault to store your passwords. The IP takes password in free text as well as key vault, but we always recommend key vault for safety purposes, right? And it will create MU logs for CDC. If at all you want to, CDC is optional. If at all you do not want to use CDC, you can still use this IP for initial load. So if you're going to use CDC, those objects are going to get created on your production database. So you'll have to keep that in mind. Benefits would be, it's going to migrate the data fast, depending upon the parallelism that we select. It's easily scalable. You can bring up the cluster, you can increase the nodes, you can decrease the node by just few clicks. If you have a secondary copy, which is read-only, you can practically do this without any impact to your production database. And it handles clobs and blobs. Okay, so clobs and blobs are handled for initial load. For CDC, only clobs are handled. We do not have any support for blob as of now. Drawbacks or limitation, it's not drawback as such, but yeah, the IP itself is free. But then the cost of running it on a cluster, you're going to incur cost for Azure Databricks or Synapse. Okay, and that will be the cost of running this IP. And blob storages, if it's in a table and you have a lot of blob storage in the same table, the migration would slow down. Okay, because what this does is it stores blob into Azure storage and it puts the URL back to the table, and that's a cloud native way of migrating the data, migrating the blob. So I'll quickly share my screen and show you a working demo. Let me just take the control. Hope my screen is visible. Right, so yeah. I'll probably talk about the cluster. What I have here, this is just a functional demo. We are not looking at performance here. I have a one worker node cluster. It is running Scala 2.12. And we'll need two libraries. One is OJDBC 8 for connecting to Oracle database. Another one is a this is a jar that we'll provide. It contains the connector to connect to the SQL database, as well as the migration code that is needed to do initial and as well as CDC migration. Right. What we're going to do now is migrate the data. It's a standard HR schema that we're going to migrate. Okay, so these are the tables. These are the 7 tables that we're going to migrate. I've already migrated the schema. The tables are already available in my SQL DB, and I'm going to migrate the data in these tables. Right. Let's go to the notebook. So the first cell is for initializing the parameters. Okay, so we've got many parameters, and I'll walk you through each of them. First one is a source parameter. It's a map. Okay, and it will give the driver the user ID, password, and URL. Okay, these are pretty self-explanatory. These are needed for your JDBC connection. These two parameters, the first one is number of partition. It decides how much partitions that you want to basically split your table into. Right now it's set to 2, but then this depends upon the size of the table and your CPUs at the source side. The schema is from which schema you want to migrating to your target database. Now, in most of the cases, your user is a schema in Oracle, but in if you have a user which connects to an application user, which is a different schema, then you can mention the schema name here. Target parameter is for connecting to SQL DB. You could use SQL DB or you could use Postgres. I mean, the only thing that will change is the connection strings. Full schema is for, I mean, basically, if you want to select all the tables from the source schema, you'll set this to true. If it's false, then it is only going to select what is there in this list buffer. And tables to exclude is, I mean, if you select this as true, and if you want to migrate most of the table but not all, okay, the tables that you want to exclude will be part of this list as a comma separated value. Run parallel is for letting the code know whether you want to run all the tables in parallel or not, and how many numbers of thread you want to use for this parallelism. This parallelism and this parallelism are totally different. Over here, one table is being divided, and over here, multiple tables are being run at the same time. Right. So let's go ahead and run this. So this is doing an initial migration. It is selecting all those tables and getting the data and pushing it into target. Oh, sorry, I have to initialize them, which I'm going to do now. Okay, that's done. Let's run this again. Okay, so if you can see the data has been migrated, it gives a log in this format. You've got schema name, table name, number of rows selected, start time, end time, and time it has taken in milliseconds, right? So let's quickly look at the tables now. If you see, the data has been migrated to the target database. And this is in no way a performance demo, it's just a functional demo, so the tables are pretty small. Now let's look at the CDC. So for CDC, we'll have to create a materialized view, which is, so you can create it manually, but we also have a code which we are going to supply with this IP. Which, I mean, it's a package that you compile and you run it like this. Okay, so if you select all here, it is going to create a view on all of the tables. If you want to, I mean, create only on few tables, you're going to pass a comma separated value here. And if you want to exclude tables and you're going to pass table names in comma separated value, but set this to true. I mean, saying that this is an exclusion list. For this demo, I'm just going to compile this package. Okay, and I'm going to run this. So it has created materialized view on all of the tables. Let's quickly test it. So I have this employee, and I'm going to change the name to Kapil. Right. So that's done. Now the change is actually already logged in my MView, and I'm going to run this process of CDC, which is going to transport it to the target database. Now there's a parameter which is run continuous. If it's false, it is going to run once and stop. If it's true, then it is going to keep on running continuously. It uses the same parameters which is source and target, which we have initialized at the top. Right? So the migration has been done. Let's quickly go to the SQL database and check what's happened. So if you see, the change has already been applied. I mean, it has come into the target database, but it is still not applied, and we'll talk about it. So we have change time. So time at which the change has happened at the source side. Change sequence, if you're doing a multiple insert updates. Okay, so the sequence on which I mean, it has happened on the table. The table name, what kind of change? It can be update, insert, or delete. The change format, okay, it's JSON, and we only support JSON right now, but we will support multiple other formats in the future. And this is what we have. I mean, this is the changed data. Right, so we have my primary key, the change type, table name, changed values, and these are all the values except the primary key. And to apply this change, we have a process which we again are going to supply with this IP. It is going to apply it in sequential manner, but if you want to do it in parallel, I mean, this code can be altered to apply these changes in parallel. If I run it now, So if you see, the change has been applied on employees, and this was the change sequence. Let's look at the data. Right. So the first name has been changed to Kapil. Okay. So that's how we apply the CDCs from source to target. So if you keep on running the process continuously on your Spark database and this process over here, practically what you're saying is that it's a replication job that is going to keep on selecting the changes on the source side and apply here. So that completes the demo of CDC. We've got one extra feature that we supply with this IP, and that is for checking the status of the migration, right? So it is going to select the count of tables from source and target, and it is going to give you a progress bar. This is mostly needed where you're applying the CDC when you're running it continuously. If you run this step in a separate notebook, you can keep an eye on what's happening and how the changes are being applied and how behind are you on the target side. So yeah, that's how the process works, and this basically gives us the speed that Narendra just talked about a few minutes back. We've got a very good speed of 350 GB per hour. We're able to migrate at that speed, the downtime that was given to us by the customer, we completed within 50% of that downtime, and that's the USP of this IP. So yeah, over to you, Mukesh, for continuing this.
Thank you, Kapil. Thank you, Naren. Fantastic talk track and demo. And everyone, I hope you like the depth of this IP that covers, frequently asked enterprise scenarios to deal with very large databases, not just for initial data load, but also for change data capture and replication. And as you saw in the demo, this is being perfected, working in parallel with more than 20 customers at the moment. And we are industrializing this IP, right? And soon our goal is to land this through the established first-party tools. But in the meantime, we would highly encourage you to reach out to us and ask questions, get access to this tool if you are stuck or if you are blocked, right? Migrating any of your customers' workload with exact same characteristics. And then we are also making a lot more advancements, like bringing graphical user interface to this IP. And intent is to make sure that anybody with basic Python knowledge, right, should be able to come and use this, consume this IP, right, and unblock these complex migrations. Now, with that, just to reiterate key takeaways, right? So we talked about common migration technical and functional blockers. When I started, we talked about how Azure databases offering help different type of Oracle workloads and different categories of those Oracle platform workloads, right? And honestly and humbly, we have acknowledged the saliency that Oracle platform brings, right, for all of us and our customers. And how is Azure database really looking to give the parity and in some cases allow customers to refactor, right, and perhaps achieve more than what they're getting on Oracle, not just on cost, but also on real perf and real application capabilities perspective, right? And Naren did a really nice walkthrough of first-party and third-party tools, how those tools stack up in different phases of this complex end-to-end migration process, and this fantastic demo that Kapil did, right? So this is just a key reminder, key takeaways that we have delivered in this session. And then most important thing, resources, right? How do you get in touch with us? So this is our alias, Azure Databases CSE, Customer Success Engineering. Please reach out if you need help, if you need to consult on some of these technical blockers and discuss customer scenarios, right? And then we also have very active tech blogs, and we have GitHub repository and download center, dedicated pages where most of these innovations and IPs are posted, right? And you'll have those links in this resources slide. And while we talked about OBB, we want to make sure that you understand OBB is not the only win we have, right? We have a bunch of other wins migrating Oracle to PostgreSQL, Cosmos DB, and SQL platform, right? And you can find multiple other case studies here, which is publicly available. And with that, we want to thank you for your time, and I hope this helps. Give us feedback, and we are now available for Q&A.